So I have the honorable job of curing you from your after lunch dip, which I know is hard. That's why I usually skip lunch if I have to do a talk in the afternoon. The nice thing is, so the title of this talk is called Small Steps Are the Fastest Way Forward. However, I was doing a keynote in Paris last month, and I sort of renamed it because the story evolves. That's basically also the motto of this story, so everything evolves, so you can never stop learning, right? So the new title of it is actually going to be this, Getting Unstuck. And it's basically a set of strategies for surviving in a rapidly changing post-agile world. Now, probably like you don't like the word agile anymore, right? Do you? Do you still like Scrum? Okay, get out. Sorry, no, just kidding. So we're going to talk a little bit about well, how companies get stuck. And these are just things you probably will recognize, well, from your own experience, basically. Yeah, I was thinking about, so for those of you who were last year, my girlfriend Kim and I were on this stage last year doing the closing keynote. She is here too, but she has a new talk tomorrow. So I'm doing this little bit of advertising. She's going to talk about social debt, which is really cool, actually. So how do organizations get stuck? Well, let's talk about quality first, right? So how do you define quality? Well, if I go to the supermarket and I buy coffee, it's sort of natural that if I want better coffee, I pay more money for it, right? So the higher the quality, the higher the price. It's the same with cars, right? If you go out and buy a car, or even a second-hand car, the more famous the brand is, the better the features, the more the features you have, the more expensive they get. That's kind of normal, right? We all accept that particular model of pricing. That's how it works, right? So that means that if you go out and select a product, and whether that's coffee or a car or beer or whatever you do, it's basically you have to do this. Well, how much am I willing to pay for this stuff versus how much quality do I get? And for everybody, there's this optimum. That can be different for anybody, right? So my daughter drinks a lot of coffee, even more than I do. Which means I can buy the better brands for her, but she just swallows it up all the time, right? So I just buy the regular coffee from the supermarket, really fine. But if she's not at home and I want to make good coffee, then I'd use a more exquisite brand, right? Which is a lot more expensive. That's basically how it works. We all know this model. The problem is, if you talk about software, talking about quality in software is pretty hard because there's so many things out there that define that quality. And you might say, yeah, but that is the same with other types of products too. So if I have a software product, I can measure it through all sorts of stuff in here, usually ending with ility or itty or whatever kind of word you find in English, right? So the problem is, except if you're Adam Thornhill, he measures everything, right? So he knows how to measure quality of software. Most of us don't do that, actually. So it's sort of like intangible. We got a gut feeling about what is good software, but we don't know exactly. And we also cannot put a price on it. It is not the same relationship between the quality of the product and the price of the product, right? You could, well, build software forever in a product that never releases, meaning the quality is very low and it costs a lot of money. We've all been in that situation probably, right? So that's where you go. Now, the weird thing is you have to find and you have to strike the right balance. Finding the right balance between quality and how much can it cost is really hard, actually. So you might say, what if I would want to build, I don't know, a small mobile app to do pricing on flights or whatever, right? Something simple. You could say, now, the sooner I get it into the app stores, the better it is. So the less time I spend on it, the better it is. Is that a high maintainable quality code there? No, it's just one-off code, probably generated by ChatGPT and not being very reliable, but et cetera, et cetera. But it's okay because that's what I aimed for, right? But if you are, let's say, a bank, another financial institution, an insurance company, or a government agency, you want your software to last, right? That needs to be running for a very long time. Who of you still has COBOL in their company? That is surprisingly little. A few people dare to admit this, probably, right? So, or you're not working for a bank. That could also be the case. So the thing is, if you want to have software that runs for a longer time, just like my clicker that doesn't work anymore. Oh, I got a message from my laptop, which I can't read. WebStorm quit unexpectedly. Wow, that is cool. Where is my mouse? My laptop is giving up on me. Crap. You didn't see this. Ignore. Poor WebStorm. Now I need to get back to my PowerPoint, which is going to be hard, because PowerPoint doesn't really work well on a Mac. Well, there goes my day. Should I quit PowerPoint now, or what? Yep, I did. I'll just restart it again. It's a fast machine anyway, right? Except that I didn't know where I was now. It doesn't want to open again. Now I'm really stuck, right? I have to tell the story from heart. How do I solve this thing? Let's kill all this stuff that I have. See if I can get PowerPoint back up. Whew. Okay, it got me so far. So yeah, we were here. Sorry about that. That's the first time WebStorm got me in trouble. Well, okay, there we go. So, for the long run, sorry for this interruption, that's about quality software, right? So, PowerPoint on a Mac, don't do it actually. So it's like, I'm going to quit doing this. So, in the long run, you need to have software that has higher quality, that is maintainable, for instance, right? That is testable or even tested automatically. So you need to do different things. And now you get into trouble, because this is where we're going to introduce the technical debt issue, right? So you all have, you know what technical debt is, right? You all have it, right? Don't say no. It's true. So there's the sort of like original definition from Ward Cunningham. Ward says, shipping first-time code is like going into debt. A little debt speeds development. That's good. So as long as it is paid back promptly with refactoring. Now, that's where the trouble begins, right? And I see a lot of people saying, yes, but our Scrum Master or our product owner, they don't want to reserve time for refactoring. And we want to reserve 10% of our time. I'm like, don't tell them that you do this, right? This is just your normal job. And it gets worse, right? Because if you don't deal with the technical debt, as Ward Cunningham puts it really eloquently, he says, entire engineering organizations can be brought to a standstill under the debt load of an unfactored implementation. Independent of what paradigm you follow, whether that's OO or FP or whatever you do, procedural code doesn't matter. It's all the same, right? And a lot of companies have this, actually. And this is a really, really big problem. And it gets worse. Well, let me show you some examples first, and then I'll tell you why it gets worse. So I was working for this insurance company about 12 years ago, I think. And they hired me as the CTO to solve some of their tiny issues. They had more issues, by the way, but I'm not going to talk about those. So they had on-premise legacy. You know how much legacy they had? They had 18 million lines of COBOL code. So 18 million lines of COBOL code. And they also had 12 million lines of Java. And this is what happened. So this is an example of their COBOL code. Now, there's a lot of issues with this COBOL code. First of all, nobody knows what dialect of COBOL this is, right? There's different dialects. They behave differently. It's weird. It's basically like any other language, by the way. Also, it's full of abbreviations. And that's because they had little space to store the variable names, so you couldn't do it as in Java. You just spent like 60 characters on your variable names. They just couldn't do that. They didn't have the space, right? Now, the third problem is it's in Dutch. That means only a few people could read it. The people who could read this, who wrote this stuff, actually, they were getting older, right? That's developers do. And they wanted to retire. Now, you see a lot of COBOL developers coming back from retirement, asking astronomical fees to do the same work they did before when they were just permanently employed, which is really cool, right? So if you want to make money, learn COBOL. I'm not joking, this is actually true. So I'll give you one more example. This is my current client, which is a well-known e-commerce company in the Netherlands. And I came there like 3.5 years ago. I'm already there for 3.5 years. Wow, that's a long time. And they had grown from a single deal on a web page 15 to 20 years ago, and it had grown and grown. They administrated everything in an Excel spreadsheet at first, really cool. And then it grew, and then we're like, oh, we need a CMS system, we need a CRM system, we need an ERP system, we need everything. So over time, they just got some software off the shelf depending on which language developers they had at that point in time, and they had all sorts of them. They had a lot of PHP, a lot of Python, and everything was in a different language. And for every problem that they found, they created a point solution, right? So, oh, we need to store customer accounts and their passwords. Who do we have? Oh, we have some PHP developers. You know what? We'll put it in the CMS, because that's in PHP. So they had 2.3 million accounts in a CMS system. Okay, I rest my case. Right? And then they started doing microservices, of course, who doesn't? And then they had to connect to all sorts of clouds and all sorts of external systems. And then the problem was that over time, they had data everywhere. Now, data everywhere sounds like not so much as a problem, except that you need to sync everything, right? And then the shit hits the fan, right? And this is where they got into big trouble. Now, the trouble they had was that they spent so much time in just keeping these systems running that they could not evolve beyond that, right? They came to the point that I call technical death, which basically means all your time goes into maintaining your old systems. There's no time to innovate. They hadn't been able to release their mobile app in 2.5 years, right? If you're an e-commerce company, that's like deadly, right? You're just dead in the water, basically. So that's a problem. And a lot of companies have similar problems. They might not be totally dead, but almost. And then the question is always, what's the real problem behind this? Now, Kim will explain about social death tomorrow because it's very much related. But I'm a simple guy, so it says, it's always the organization, right? It's never the code itself. It's the way the organization deals with stuff like technical debt and knowing when to innovate. And knowing when to innovate is really well put together in something called the innovator's dilemma. Have you heard of it? It's pretty cool, actually. It's a chart. Basically, there's a book too, but I just read charts. And this is it, basically. So you come up with a new product, which is really cool. To give you an example, I worked for a company that invented the smart thermostat 15 years ago in the Netherlands. Really cool stuff. And then they just added new features to it, and they thought it would sell more and more and more. And then they got to a point that no matter what they added to the product, it didn't sell more than it already is, because it was sort of saturated, right? And they actually added traffic information to the smart thermostat, which was a device like that hang on the wall in your house. It's pretty cool to have traffic information in the wall on your house. Not as useful as in your car, but you couldn't take it with you, right? So, and so they got to the point that no matter what they added, they didn't sell more. And at that point in time, other companies came in, big companies like Google and Tado, and they invented products that were based on newer technology, being able to launch much more features. And at that point in time, this company should have reinvented itself. It didn't. And then it stopped to exist. They went bankrupt, basically. Well, they were bought by a large energy company, and you know what large companies do with small companies. They eat them for breakfast, and they just vanish. So I took the team, and we went elsewhere. So this is a real problem, right? And the question is, what do you do? Well, you call me, basically, right? So this is a good point to introduce myself. I'm Sander. I'm from the Netherlands, but you can probably hear that, right? I'm an independent dad. I speak a bit, I travel a bit, I write a bit. I'm sort of like the CTO for this e-commerce company called iBOOD as a freelance, which is really nice. And this is the rest of my data. Not very interesting. By the way, iBOOD, we got it out of the crap that they were in, and we actually won the Website of the Year award 2 years ago. And I was like, did we pay for this? And the CEO said, no, I didn't know either. And I was like, cool. This is my first award ever, right? So that's really cool. I never win anything, not even with a lottery. So to just show you that I'm a programmer, I've been writing code for 45 years already. And if you can see from my name, I'm double object-oriented. It gets worse, because I live in Amsterdam in the Javastraat. I'm not kidding you, this is actually true. This is the view from our window. It's really cool, right? I also do write a bit of open source. This is our TypeScript framework for writing microservices, really cool stuff. That's the intro, right? So now the question is, how do you get unstuck? Because that's basically what you want to do as a company. So you need to get beyond technical debt. You need to get beyond the innovator's dilemma. First of all, you need to recognize them. So I showed you how to recognize them. Now is the question, how do you get beyond it? Now, I'm going to show you a bunch of stuff. You might say, oh, it's interesting. But you could also say, yeah, it doesn't work for us. Large companies will probably say, no, it doesn't work for us. We're an enterprise. Enterprise have different rules, right? So that's why I'm also using this, the just sharing principle, which means stuff that I present works in our context. That doesn't necessarily mean it works in yours. So please take out of it what you like and take it with you where you go. So The problem is that you have to get out of this point where you just do maintenance on your basic systems, because you need to innovate all the time. That's basically the part of being a company. And that means you go into what I call continuous renovation mode. This is my bicycle repairman in Amsterdam. He maintains my bike. Really cool, really old-fashioned. I really like this thing. That's why I put him on the slide. But you have to sort of keep everything running and at the same time move away from the old stuff, moving into new stuff, whatever, right? So that means you need to figure out how to spend your time. And this is where it mostly goes wrong with companies. Because, well, while you're renovating, you always need to keep the shop open, right? That is just how things work. You cannot just say, we're going to shut down a website, we have no income for the next year, and we'll build a new platform for you. There is no such thing as greenfield anymore. It doesn't exist anymore. Well, almost, unless you're a startup or something, but I'm jealous about startups. So, anyway, so that means you have to think about how to get out of here. And the only way to do that, and that's hence the title of the previous title of the deck, is to move in small steps. That is motivated by this thing called Gall's law. Now, there was this guy called John Gall. He said, a complex system that works is invariably found to have evolved from a simple system that works. Well, that makes kind of sense, right? And then he says, a complex system designed from scratch never works. Keep that in mind, right? So the insurance company that I worked for, they had tried 6 times before, 6 times 2 years, in building the next new big system. They failed 6 times. And I was like, this might not be the right strategy. So if you are in a project like this, saying, wow, we're going to rebuild it from scratch in this really complex big system, get out. It doesn't really work. What he says, you need to start over with a working simple system. So you start with the smallest thing that you can build. And then the next question is, how do you find the time to do that? And that is where the Cynefin framework helps. Have you seen this? Good. For those who haven't, I'll explain it really, really rapidly, right? So this is a model that divides your problem space into a number of zones. In the clear zone, there is a best practice for the problem at hand. That means you apply the best practice, you implement it, you build it, done. Easy stuff. You can do this in a waterfall, right? Even in Scrum if you want. Yeah, I'm not sure what's worse. But anyway, so then you get to the complicated zone where there are a number of good practices. They exist, right? If you do IAM, if you need to select a company to do your IAM for, you can go to the big cloud vendors, you can go to Okta, you can go in many directions. Just don't implement it yourself. We've tried. It's not a good idea, actually. So keep your accounts somewhere else, basically. So you have to choose one. Do some analysis, pick the one that fits you best, probably in the cloud that you're already running on, and do the work done. This is still doable. But then you get to the complex zone. In the complex zone, if you are in the problem space of the complex zone, that means there is no best or good practice. There are just practices emerging. They might come out of what you try to do, they might not. Right? This is the area where you could, well, continue on what you're doing or fail or do some more experiments, etc. It could be worse. You could be in the chaotic zone. In the chaotic zone, that means you have no idea where to go. This is usually very short-lived because there's always somebody who then says, oh, you know what, we're going to try this. And you better follow because that's the only way you can get from the chaotic zone into the complex zone. And later on, years later, you go into the complicated zone and then the whole cycle starts again. Now, the problem is that most of us are in here. We are not in the comfortable, complicated, and clear zones. Well, otherwise you wouldn't be here. You would just be pushing out code in a low-code, whatever tool thingy. And you're not here because if you are here, that means you're trying to learn. If you're trying to learn, you're probably in the complex space, right? So I'm addressing the right people here, I think. So the question is, what do you do? Or how do you recognize that you're in this particular zone? Now, Liz says, basically, I'm just going to read the last 2 of them. She says, well, if somebody's done it, but not in this context. So yeah, we did. Somebody did IAM, but just not in an e-commerce context. Could be, right? Not true, but nobody's done this before. If you're there, you're in trouble, right? And the only way out of this trouble is to run experiments. Now, here's the interesting thing about experiments. Everybody thinks they are doing experiments. A lot of us are actually not. So Jeff Bezos has a really nice quote about it. He says, most large organizations embrace the idea of invention or innovation, but are not willing to suffer the string of failed experiments that lead there. Right? Yeah, we want to innovate, we want to do something new, but we're not going to take any risks. That is not the way to go. The thing you need to do is you need to experiment. And an experiment is basically this. It's a test done in order to learn something or to discover if something works or is true. It could also be false. But you have to be willing to take that risk. Otherwise, you'll never get out of this stuff. Also, if you do not make any decisions and you are in the innovator's dilemma or in technical debt, you just vanish, right? Taking no decisions is as good as taking, well, no decisions and just stay where you are. If you stay where you are, you'll go out of business. So that's the problem case. And then you need to take small steps. The question is, what can you do? Now, I'll show you 4 aspects of taking small steps. I'm going to look into 3 of them. I'm not going to do the, let's say, the microservices or the small component part of it, but I'm going to look at delivering features instead of projects, right? We need to stop doing projects. Projects are doomed, basically. They shouldn't exist anymore. We need to go into shorter cycles. If you think you're in a sprint of 2 or 3 weeks, that's short. It can be a lot shorter. And shorter means better feedback. We also need to look into how teams operate. So we're going to do that too. We're not going to look into this. I'm going to skip that one. So let's look into delivering small features first. How do you do that? Well, first of all, to get from a chaotic context into a complex context, you need to define the dotted horizon. You need to identify where you want to go. Because if you don't know where you're going, you might as well do any arbitrary experiment and you never know where well, basically you don't know where you're going. So we did this exercise, and this is the example I have from the e-commerce I work for. They said, well, we want to be Europe's leading deal site. Now, we're in Greece, nobody's heard of it, so we're not there yet, right? So connecting our community of consumers, so apparently we have a community. On a daily basis, we have daily new deals, yes, with surprisingly attractive A-branded products. That is quite a dotted horizon, actually. We need to do a lot of stuff. To be able to say we're Europe's leading, we need to be in more countries than the 6 we are in now. So we need to identify how to get to new countries. That is not just a tech problem, that's an organizational problem, right? But as tech, it gives us direction where to go. It means that all our software needs to be multilingual. It also means we need to be multi-tenant, which makes stuff a little bit harder, actually. So that's the thing to do, right? Find where you're going, and then decide how to spend your time. Now, the problem at this company was really big because they hadn't released anything yet in 2.5 years, right? So I said, okay, what we can do, let's say, spend 30% on our innovation and then the rest on maintaining all this shit, or we could do the other way around. We can agree that we're going to spend 70% of our time on innovation and the rest on keeping everything running. So we do just enough effort to keep the older systems running and occasionally add a new feature to it, but the rest of it goes into innovation. And how do we do that? Well, what we do is we set up this group of people, basically sort of like the managers or product managers of the main departments. I'm in there from tech. One of my lead developers is in there. The COO is in there. The CMO, the CPO. Those people, the people who can make decisions whether or not stuff goes in the right direction. For every idea that comes in, we make these decisions. We say, okay, does it help us to reach the dotted horizon? If not, just throw it away. Spend as little time on it as you can. Then the next question is, can we actually do this? Is our tech so far that we can actually handle this? There's stuff we cannot do yet because we have no idea how to do it. Best put it on reserve, right? And then the next question is, can we actually do this because it's small enough? If it's not, we go back to the person who posted the idea and say, well, please break it down into small pieces. And they usually do. And then we're going to say, okay, is this the most important thing we can do with our time now? Because you can only spend your time once. If there's other stuff that's either more important or more urgent, we'll do that first. And then we'll put it on this someday maybe list, which is a list that we revisit every 3 months. Usually what happens to the stuff in there, it goes away without us spending time on it, which is really nice, actually. So we don't have to spend time on it, and it goes away anyway. So bad ideas just disappear, which is good. And this is how we, by the way, technically do it. This is Jira. Don't look at it. I don't like Jira, but well, anyway. So this is the stuff that's on the tech board. These are the bigger topics. These are helping us to get to where we want to be in the end, the dotted horizon. And this is for the smaller stuff. We call it the general board. I don't know why it's called the general board. It was that way before I came in. And then we have like a Slack channel that's called Ask Tech, and people ask questions. They do that all day long. Even questions that are not need to be answered by tech, well, we'll just answer them anyway, right? We're just nice people, and if we can solve them in 10 minutes, then we're okay with it. So if it does take more than 10 minutes, we say, okay, wait a minute, you need to put it on the other board because it's too big. So that's basically how we split up things. So what's the next step? So the next step is Go work in shorter cycles. Now you're like, what? We're already working in short cycles. We do Scrum. Who does Scrum, by the way? Good. Oh, just kidding. So here's the thing. Software development approaches are basically an evolution, right? There is no endpoint yet. We're not there yet, right? So when I was young, we did waterfall. And me being young, that means like 45 years ago, something like that. People did waterfall. It failed all the time. There's a single pass model, meaning you go from, this is what I want, until 3 years later, we'll put it in production and nobody knows anymore why we built the system, right? That's basically what happened. And then we went into stuff like rational unified process in the 90s. And they had cycles like 4 to 6 months. That was already quite a surprise to most people. Like, what? We can do multiple iteration? Yeah, sure. And then we went into doing DSDM, late 90s, early 2000s. Shorter cycles, and then came stuff like Agile, XP, Scrum, and all the other ones came along, right? And we went into cycles from 2 to 4 weeks, depending on how fast the technology helped us out. But now we're in the time that we can actually put stuff into production on the same day that we invented. Or do that multiple times per day, which is basically continuous deployment if you've automated everything. Now, the nice thing is, the shorter the cycles are, the sooner you get feedback. And feedback is super relevant because that's how you get better. That's how you achieve quality. So what we do is, whatever one of the new stuff that comes in, we just build a basic version. And we'll put it out there to the business and they're like, yeah, but it's not finished. No, we know. But it's good enough to work with. And now you can complain as much as you like and put it on the general board or on the Aztec channel. And if we have time, we'll improve it. Otherwise, we spend stuff on stuff that's more important. Right? Those are the decisions that we make. And that's really cool to be able to do that. And the nice thing is, if you're still using sprints don't work, right? You all know that, you're just afraid to admit it because otherwise maybe your boss is in the room or whatever, right? So here's the thing, this is a burn down chart from a project I visited in Belgium about a decade ago. They estimated the work as you do in a sprint, and then of course by the end of the sprint they had work left. You recognize this? Yeah, you all do. I know you do. Because we suck at estimation, basically, right? We don't know how to estimate. That is because we are mostly in the complex zone, meaning we have to experiment, meaning we cannot estimate it. It's very logical, basically. If you're doing COBOL, well, I believe you can estimate it. I work with COBOL developers who can estimate almost to the minute how long it would take to do stuff. Because they've been doing it for 25 years. Nothing changed. Which is nice, but and then the next sprint came along, and the next sprint, and the next sprint, and they all failed, basically. So the manager and the project manager, yes, there was a project manager, they called it red sprints. It's like, oh, these developers are just stupid. They don't know how to do the work. They cannot estimate. They cannot actually do the work. You know what? We'll call in 300 people from a company across the sea somewhere, and I'm not going to mention it, but they pulled in 300 people to the project. Of course, that made the project even worse, and it failed miserably. The project manager was fired, his own fault, and it failed, even though they were doing Scrum, right? So yes, you can fail with Scrum, because even in Scrum, there's all sorts of stuff like this happening, right? Well, you could finish early. What then? Well, you cannot add stuff to your current sprint. So what do? Well, you go to Athens. I don't know. Or late acceptance, right? You've done all this stuff, and then they say, sorry, we have no time to test it. It doesn't get accepted. Or you're going too slow, right? That happens most of the time. Or like people add stuff to it anyway, like scope creep, and they say, oh, wait, we need to have this button anyway. Can you just push it in? And I'm like, no! I'm like, please? And we still say no, of course, because yeah, but you don't do that in sprints. You don't add stuff to the sprint. That's the problem with sprints, right? They don't work all the time, or usually they don't, because progress is not really linear. It goes from some of these sprints, you have a lot of progress. Other sprints, you don't have any progress at all. And the same goes for days and even half days, right? So where do you go? Well, you go into define your own process. Agile is not a process. Our good friend Alan says, he says, Agile is not a process. Agile is the ability to create your own process. So you have to tweak and tune how you work depending on where you're going and what you're doing. That's very different than saying, oh, we have these sprints, they last 2 weeks, and if we can't fit it, oh, we don't know what to do. Just tweak the process. Even Scrum is tunable, right? Even though the Scrum guide doesn't allow you because there's the rules of Scrum, doesn't matter. Just tune it to what you're doing. And then move into continuous delivery, right? So continuous delivery, basically, if you follow Jess Humble says, if it hurts, do it more frequently and bring the pain forward. This is about software development, right? This is not about marriage or whatever. Oh, just kidding, just kidding. So, yeah, so here's the problem, right? If you have these big monolithical systems and you deploy them every 3 months, there's a huge amount of change. That huge amount of change needs to be tested. It's integrated into your system's landscape. That means the longer you wait, the more you need to test. So you do this once every quarter, and after a while, you realize that you are not able to release every quarter. You go to releasing every half year. Even worse, you could go to releasing once a year. I had a client that actually did that. And the next step was they didn't release at all anymore. They just couldn't release anymore. That's terrible, right? So the problem is, of course, there's too many dependencies. This is, by the way, the actual systems landscape of one of my previous clients. I'm not going to tell you this, but the people in the Netherlands will know the yellow colors. They drive through the country on rails, basically. This is their systems architecture for the customer service department. Every rectangle is a system. So every business process they changed or re-implemented or whatever they did needed to go through at least 8 of these systems. They could not get that tested. They went slower and slower until they got to a standstill, which is, metaphorically speaking, for a company that runs stuff on rails, not a good idea. So that's the problem. So it's basically what Jason says, right? So if you miss the bus, but you know there's a bus after 5 minutes, you're not worried. If it's the last bus, or if the next bus comes only along in an hour, you're in trouble, right? You have to wait for an hour. And that's the same with releasing software, right? As you can release every 5 minutes, let's say you can release every 5 minutes. We do that, by the way. That means it doesn't matter if it's in this release or the next one. That's just 5 minutes, literally, right? So the shorter your cycles are, the better you can do. That means if you break down your software in all sorts of small pieces, let's call it services for now, and you release every one of them independently of the rest, you're in a much better place. And that means the deltas between now and the next release are really, really tiny. And if they're really, really tiny, well, then you get feedback immediately, right? And you can easily test it. So it's a much better way of doing this. And then you need to automate everything because you cannot release every 5 minutes. You cannot do continuous deployment, automatically pushing stuff to production if you don't have it automated. So you need to have full CI/CD pipelines and you need to have the quality built in. It's just like Edwards Deming says, eliminate the need for massive inspection. So there goes your code reviews, your pull requests, whatever reviews you do, manual testing. Don't do it, he says. He says, don't have a need for massive inspection by building the quality into the product. Right? That means that you'll have fully automated CI/CD pipelines. This is ours, by the way, or one of ours. It also means you need to start automated testing right away. If you're not doing this yet, you're doing something wrong, basically. That's easy to say. So you cannot rely on this huge ice cream cone of manual testing. You need to just turn it around because it needs to be the other way around. You need to have automated tests everywhere, basically. And the nice thing about having automated tests everywhere, and here's our pipeline again, so you can see where we have them everywhere. From the unit tests that are run on my machine until I push stuff to in the pipeline, it runs the unit test again. It does static code analysis using Sonar, then we deploy it, then we do the API test, integration test, all the way down to the end. Even in production, by the way, we test. Because even when you go to production, stuff might break. So we run tests on production as well. If they fail, nobody looks, but we do it anyway. It's a matter of choice, right? And then you can learn how to code with confidence. Because if you have everything automated tested, you can just push out the code much more easily. I think we have like 2,500 tests on our open source framework. Means if I do a small change to it, I'm pretty confident it will work. By the way, the reason, of course, that this developer is praying for his code to work is that he's working in light mode. You don't do that. So the last step. And I need to do this quickly because I run way too low. Oh, wait, let's not put it there. So talk about teams a little bit. Now, the problem with software development is it's complex by nature. It's very, very complex. Dijkstra said it already, right? The program has to be able to think in terms of conceptual hierarchies that are much deeper than a single mind ever needed to face before. The single mind is the problem here, right? There is no single mind anymore in software development. When I started writing code 45 years ago, it was damn easy. I wrote it in Pascal on the Pascal compiler. I had compiled, work, done. And if we wanted to deploy it to somebody else's machine, well, here's the floppy disk. That's the way we run the world, right? But it doesn't work like that anymore. It's way more complex, right? You need like 10 people to keep Kubernetes running, actually, for instance, like, and all these other stuff. If you do Kafka, oh yeah, just hire another team, right? It gets really complex. So to one of my clients, we did a sort of like an investigation to what technologies are we using. This is, by the way, the company that went bankrupt. Duh. They had like 40 developers to keep this whole stack running, right? They just couldn't, right? They couldn't cut with it, and for the right reasons. So that means the thing you need to realize is that if you are a developer, like all of us most probably, is there's so much you don't know, and that's okay. I got this question this morning from somebody saying, but how do I keep up to date? Well, the answer is you don't. Well, you do, but you don't have to know everything, right? You cannot know everything. I have people on my team who know a lot more than I do about a lot of topics, and that is okay, right? You don't have to control everything. It's not what we do. So that means the smallest unit of software development is not anymore the individual, it's the team. And then the question is, how do you make your team operate in the best way? And the answer is, you need to make it as autonomous as you can. So this is what I realized over time. This is a jazz concert that we were at last year, and you see these people work in different subset of the bigger team to do smaller songs in different flavors, right? So if you look at a bigger jazz band like the New Cool Collective in the Netherlands, you can say, well, there's all these people having different skills, and with these skills they form smaller groups of people who can do different stuff. If you have a pianist and a singer, you can do a ballad, for instance, right? If you have 3 horn players and stuff, you can do other types of music, and that's the whole point. So it works the same way in software development, I think. That means that there's a whole bunch of people having a whole bunch of skills, knowing all sorts of stuff, and this is the total group that you need to bring your software forward. However, the thing is that what you realize, and there's some pictures of collectives in action, just people on in a room, right? And if you do that, you realize that in order to be working as good as possible, you need to make them as autonomous as possible. And autonomy is really complex because for most people, autonomy is out of their comfort zone. I have a developer on my team, and she was like, the first time we started doing this, she was like, yeah, but what do you want me to do today, right? Do you want me to work on the new TypeScript thing, or you want me to work on the Python ERP system? And I said, well, it's up to you. And she said, what? I said, well, it's up to you. What's more important? And she said, well, I think this one. Okay, work on that one. Yeah, but the other one is also important. True. So make a choice, right? You choose. That's really hard for people, right? And the thing is that you cannot tell people you're now autonomous, right? It means like if I teach them how to draw an owl, like I say, yeah, you draw 2 circles. The rest of it, just figure it out, right? It's not, that doesn't work like that. What I did learn is this. If you have a lot of rules, people will do stupid stuff. They will just act according to rules, right? If you go to the Netherlands, we have signs on the streets. Like, it's mandatory to have at least 2 signs every meter. Otherwise, people don't know what to do, right? And if you go to, I don't know, Middle America, there's no signs at all. People still ride on the road. So if you give them less rules, people will think more. So the clue to this is, wait, it's the same slide again. Give them fewer rules. This is a crossroads in Amsterdam where they, at some point, did an experiment. They removed all the lights and whatever that was there and just said, figure it out. And people did. They started communicating to each other, figuring out what to do. And that's really cool. So here's my team. So what I did is I said, you know what? This is a French code, by the way. I forgot to put in the English one. But it basically says, perfection is not when there's nothing more to add, but when there's nothing more to remove. And that is the other way around, and is intuitive for most people. So if I look into my own team, this is my team. I'm in the picture as well. We don't do Scrum. We don't do Kanban either. We don't care about methodologies, basically. We don't have sprints. We don't have a Scrum master, no product owner, no stories. We don't estimate. Well, only on a very high ballpark level. We don't do retros either. They're boring. We're actually now on the path of removing the stand-up meetings as well. Which is really stupid because I was here ready for the stand-up meeting yesterday. And then I called and said, where is everybody? Did we abolish it? And I said, no, you're in a different time zone. That sucked. Anyway, so here's the thing that we realized. What if we just solve 1 problem per day? What if we break down this problem into smaller items that just fall off this tech board or Aztec or whatever they come from, and we'll just group stuff together. There's just people doing stuff. Like, well, for some item you need this skill set, and for another item you need this skill set. And if you do that, you come to something which I call microteams. Now, microteams, basically what you do is every time something new comes along, and you're like, oh, you know what, I'm going to pick that up. It's up to you to whether you do that or not, right? And then somebody else might say, you know what, I'll join you because this is really interesting to me, or I know a little bit about this. Let's do this, right? And then you do some work, you check it in, feature goes out, so no projects, just features, and your report is done, you go away. So some examples, and then I'll lead you to the end of the talk. This is a developer, a Java developer, and an ops guy. Okay, they work together on some item, some infra item, and they learn from each other, which is good. Or here you have, this is my current team. This is 2 back-end developer and a front-end developer. You can see that he's a front-end developer. He's like, what are you guys doing? No, no, he's really good. He knows a lot of stuff, by the way. And he's our CSS expert. CSS is damn hard, by the way. So this is 2 developers, 2 Java developers, and a tester. You can recognize the tester. He's standing. This is manual testing, right? So, or this one's also nice. This is a developer and an architect. The architect is praying for it to work. The developer knows it's not. So you can do stuff in different settings, and it doesn't matter. So it's different every day. So you get to different ways of working, learning from different people. There's nobody telling you what to do or who to work with. And you can see that if you do this for a long run, people tend to have some preferences. I have a few people on the team that I like working with, and I work with them mostly on a daily basis. And other people like working with them too, but it doesn't mean I'm not working with the other ones. I do too. And they do with other people's, and it mixes up. We have a developer on the team who prefers to work alone. That's also okay. It's less effective, but that's his style, basically. It's how he is. He used to be a pro football player, by the way. It's an interesting challenge, an interesting change. So, to round things up, I think that software development is way too complex to leave it in the hands of managers. No, just kidding. But it's really complex. It means in most of the cases that you're in, and if you're in a technical debt or innovator's dilemma session, you need to make time available to get out of it. You need to get out of that complex zone, and that takes a lot of time, a lot of guts, and a lot of experimentation, right? So if you are in a complex zone, and most of you will be, you need to do stuff differently. You need to go into what we call continuous renovation mode. And if you are in continuous renovation mode, this is what we do. We just deliver features. We don't deliver products or projects anymore. We just do features wherever they are, whatever they do, right? And we do that in very, very short cycles. I didn't precisely know that, but we put stuff to production about 20 to 30 times per day. Usually it goes okay, sometimes it does not. We had really weird issues with our URLs this morning. I hope the team solved it by now, but that's how it goes, right? Sometimes it breaks. It's an experiment. Everything you do becomes an experiment. And that's nice, because that's the stuff that you learn from. And you can do it with even smaller teams, like sub-teams or micro-teams. We call it micro-teams. Being in a larger collective that builds the software, that does the work, usually in a domain or in an area or in a bounded context, can be anything, right? And then the last thing is, well, you build smaller components, because otherwise you can never do this. And automate everything. So, to conclude, less is more, actually. That is as simple as it can be. I cannot put it any better. This is what it is. The less process you have, the smaller the teams are, the shorter the cycles, the smaller the components, it's better. Just better. It's easy. I don't quantify it, but that's what it is. And we just solve one problem per day. It's really, really easy. Actually, I do this in my personal life as well. That means that I still have like 200,000 problems to solve, but I'll get to it later. And now I'm here, right? And I have to drink beer. So never stop learning, by the way, because that's in this field mandatory. If you are in complex zones, you can only never stop learning. And never forget to have fun. That's in my deck all the time. That's basically it, I guess. So thank you for allowing me to go a little bit over time. I hope I'm not keeping you from the coffee. Please join my girlfriend Kim's talk tomorrow. She'll talk about social death, which is very much related to this topic. And enjoy the rest of the conference.